Okay, so let's have a go at this in MATLAB. Now, we're going to do essentially everything numerically, although you can do symbolically if you really want to. Just for completeness here, let's run through a simple multiplication using symbolics. So the first thing you've got to do is you've got to define all your numbers, all your variables to be symbolic. So I'll just recall that from the command history. And let's define a matrix A that's symbolic. There it is. And let's define B. And remember that the comma separates elements along a row, and the semicolon starts a new row. So there we go. There's A and B. I can say A times B if I want to. There it is. Now where do you go from here? I don't know. You can start substituting in for A's and B's, I guess. You can invert A, I think. Let's try it. Yeah, there it is. There's the inverse of A symbolically. This gets extremely cumbersome for matrices other than n equal 2 or n equal 3. So there's not many places we can go with this. Let's go ahead and clear workspace and clear the command window. All right, so let's try this with numbers rather than variables. So we'll do this numerically. I'm going to define A as 1, 1. So each element in the matrix is its row and column. Now this isn't going to last long, but I'll start this way. So there's A and B. So if I want to multiply, let's say C equals A times B, and I'm going to go ahead and let that echo to the screen. Here we go. You get 35 and 65. So if you want to work this out by hand, you can. Try multiply A by B, you should get that. Let's go ahead and clear the workspace here. Now, how would you invert A? Well, there's two ways to do it. There's the first one. And if you want the other way to do this, you write it out. There we go. Get the same answer. Now, what happens when you divide a number by itself? You get 1, right? So if I divide 5 by 5, I get 1. If I divide E by E, I get 1. Well, what happens if I multiply the inverse of A times A? Let's try that. There. This is called the identity matrix. The identity matrix has 1s along the diagonal and 0 everywhere else. And it's called the identity matrix because when you multiply any matrix by the identity matrix, you get the original matrix back. This is the matrix equivalent of multiplying by 1. Well, how do I make an identity matrix? It seems like something we would need a lot. Is there a command for it? You bet. So in textbooks or when you're working by hand, the identity matrix is almost always represented by a capital I. And apparently the folks who were working on MATLAB decided that didn't fit with the syntax they wanted to use. And so there's a command called IEYE. You can see it over there. And I'm going to type it in here. So a 2 by 2 identity matrix, you just type in EYE of 2, and there it is. And of course, you can make an identity matrix of any size you want. So there. So if I say, let's recall A here. So A times EYE of 2 better give me A again. In fact, let's do this. Let's go A minus EYE 2 times A. And I get 0. Now you'll notice here that I said A times EYE of 2, and here I reversed it. One of the things about matrix algebra is that order matters. Let's see. I'm going to clear the command window here. And I might even clear the command history. Okay, let's make a matrix B now. Let's maybe make it 2, 3, 4, 5, just something different than A. So A times B, B times A. I got two different answers, didn't I? So A times B minus B times A, if those were scalars, those were just numbers, I'd get 0. I don't. I get something else. That means A times B is not the same as B times A. So when you're dealing with matrices, order matters. Now let's try some other things that are handy here. Let's explore some more in MATLAB. One of the things you see a lot is something called a matrix transpose. You can see I've got it up here loaded up in the help window. Let's hit that. And I will pull this over here so you can see it. The help window shows up, and I'm going to click on that. So there's this thing called a transpose that we'll see a lot. And what a transpose does is it rotates the matrix about its diagonal. You can see there's two ways to do it. One is a dot, single quote, and the other one I can just type out transpose. So let's look at A. Let's bring A up here again. And let's type in transpose of A. Hit return. You can see 1 and 2 and 2 and 1 have reversed each other. What they do basically is they reverse the two indices, and the diagonal remains the same. Now the other way to do this is to, little shortcut there, use a dot and a single quote. That also gives me the transpose. Now this is not going to be 0. And it's not going to be the identity matrix. Notice that the diagonal goes to 0 when you subtract a matrix from its transpose, or vice versa. But the off diagonals, there's no reason to think those will be 0. Now let's revisit matrix multiplication for a few minutes. I'm going to clear the command window, and I'm also going to clear the workspace. Let's pull up A. Let's do this symbolically one more time. So I've defined a whole bunch of symbolic variables there. And I'm going to go ahead and make an A matrix. You can see I mistyped right there. So let's fix that. There we go. And let's do the same thing with B. Right, so what would A times B look like if you did this all out by hand? There you go. So if you want a little practice with matrix multiplication, go ahead and work that out. Write down this and that, multiply it out by hand, you should get that. So one last thing about matrix multiplication. Let's look at what the dimensions of the matrices need to be in order to be compatible. So I'm going to clear the command window, clear memory, and let's make ourselves an A matrix that is now 2 rows and 3 columns. Okay, nothing wrong with that. And let's make ourselves a B matrix that is now 2 columns and 3 rows. Also fine. Now, can I multiply A times B? I have 3 columns in A and 3 rows in B. So yeah, I can do that. Now what size am I going to get? 2 by 2. What happens if I do it the other way around? Get 3 by 3. Now let's try something that isn't compatible. What happens if I try to multiply A times the transpose of B? By the way, what is the transpose of B? What does that look like? Okay, it has 2 rows and 3 columns. So what if I type in A times, is that going to work? No. Incorrect dimensions for matrix multiplication. Remember, the number of columns in the first matrix has to equal the number of rows in the second. What if I decided C equals A times sorry, B times A. C was 3 by 3. Could I multiply C times B? Sure. There we go. Could I multiply C times A? No. No, I can't. The dimensions don't match. So there we go. These are the basics of pushing matrices around in MATLAB. I hope this helps, and we'll talk to you next time.